in this video, we're going to answer a question, and that is, why is any number divided by 0 undefined? Now, by answering this question, we're going to actually get an introduction into what a rational function is, okay? So in order to answer a question, we are going to look at the function f of x equals 1 over x. So what we're going to do here is we're going to borrow an idea from calculus, and that idea is what it means to be a limit. So we're going to start making numbers large, small, and approach a very specific numbers, and we're going to see what kind of behaviors start to happen with my graph. So in order to understand that, we're going to start with just a table of values here. And let's start with the obvious one here, and that is, what is y when x is 0? We already know it to be undefined, but now we're going to take a look at why that is the case here. So another good number to start with would just be a positive 1. So I know if I plugged a positive 1 in here for my x, I would have 1 over 1, which would result in just an y value of 1. So now I have the point 1, 1, and I can go graph it over here. If I were to go to another one, let's say 2. If I plug in a 2 for my x value, you would notice I get the y value of 1/2. And if I plugged in a 3, we would get a 1/3, and a 10. I'm going to make a jump here, I would get 1/10. So now let's go plot those points, and let's start to notice what's happening here. So if I plug in a 2, I have 2 1/2, I have 3 1/3, and then we have our 10 and 1/10. So what we start to notice is I start getting closer and closer and closer to this x-axis, but I never actually get there, right? So if I picked 1 million, I would have 1 over a million. If I had a billion, so on and so forth. So that fraction that we would get over here in my y column gets closer to 0 without ever actually getting there, okay? So now, instead of using whole numbers, let's use fractional numbers, right? Something between 1 and 0. So let's start with the easy one. We'll call that 1/2. So if I plug in a 1/2 up here for my x, I'll come down here, do a little side work. I have 1 over 1/2, which if you'll remember from our rational function operations video, we would know that that is 1 times 2 over 1. I'm multiplying by my reciprocal, and I get a y value of 2. So if I plug in the 1/2, I get a y value of 2. Same thing, I'm going to go ahead and jump to that 1/10 number. I would get a value of 10. So what we can do is go graph those as well. So if I go over a half on my x-axis, and then I would go up 2, so I'm going to plot a point right there. And the same thing, I would go over a 10th and up to 10. So now what we start to notice is another curve going the upward direction. So again, if I never actually get to 0, if I just continue to use numbers that are just slightly bigger than 0, like 1 over a million, I would have to go up 1 million for my y-axis. So the closer I start moving towards my y-axis, I notice that my y values start to get larger and larger. Now, let's go deal with negative numbers. So again, we're going to start with the -1. I think that one's a pretty easy one to look at, and notice that if I plug in a -1 for my x value, I end up getting a -1 for my y value. Then if we try, let's say we'll plug in a -2, we get a -1/2, and then we'll go ahead and jump up to -10, we get a -1/10. So let's go ahead and plot those. So I have -1, -1. I have -2, 1/2, and again, if I jump all the way out here to 10, and that's not actually 10, that's 9, but I know that it's going to be somewhere in that area for the, if my x value is 9, 1/9 would be how far I move from that. Then if I do the same thing, I use numbers between -1 and 0, I get -1/2, and the same way I multiply by the reciprocal, I get -2, and if I use -1/10 or any number that matter, closer and closer, I get a large number, -1, -10 there. So now let's plot those. I have -1/2, -2, -1/10, and now I have -10, and we can start to see we have kind of a reflected image of that same curve that we had when we started this thing, okay? And now, here's where we can start to see what's happening and why is 0 in the denominator or any number divided by 0 undefined. Well, we can answer it by looking at it this way. As I start to approach 0, as my x gets closer and closer to 0, on the positive side of things, right? When all of my x values are positive, I can see that my graph starts to curve upwards and my y goes towards positive infinity. And this is the idea of limits here, in that as I start getting closer and closer to 0, my y value gets larger and larger and larger. Now, if we look at it coming from the other way, if I look at it coming from the negative x values, right, as I start to get closer and closer to 0 from the negative side, I can start to see my y values start trending towards negative infinity. They start getting smaller and smaller and smaller. And so because I have this divergent action going on with my end behaviors, that's what tells me any number divided by 0 would be undefined, because I have two different things going on here. I have, as I approach it from the positive side, my y starts to go towards infinity, and as I start to approach it from the negative side, my y's go to negative infinity. So I don't have end behavior going towards a very specific number, therefore it's going to be undefined, okay? And so that is what is a rational function. And this here is a parent function of that rational function, much like y equals x or y equals x squared. All right. Now, in the next few videos, we'll start to talk about how we can shift, move, change all these functions and what happens when we start getting more and more complicated polynomials in both the numerator and the denominator. We're going to talk about different features and attributes of those graphs as we start to graph them. Hope this video helps, and we'll see you in the next one.